Hi, my name is Adrien Rousseau. Today I want to talk about the addition of the real numbers. It's done in space in our model. I've talked about space already, but there's a few things that can be said. So we'll go through space, then through Space-Time Theology, and then we'll go through the axioms of the real numbers related to the addition. As mentioned before, space is what you use to join extensions. So you have two extensions, you join them, it's a new extension. What do we mean by joining extensions? Poincaré, a French mathematician, thought that numbers in space are all about movement. So you move this, and then you move again. That's what you would mean by joining two extensions. The interpretation of space by Poincaré is all well and good, but for our model of the real numbers, we need something a bit different. We need something much closer to what Kant has described. First, for Kant, space is an infinite given quantity. It's important because we don't want space to get progressively built. When we join two extensions, we just want to highlight two parts of this infinite given quantity, and it's just extracting what we need from it, but it's already there. It's key because we want space to be timeless. We want space to be orthogonal to the time aspect that we add for multiplication. So space has to be like the space that Kant described as an infinite given quantity. Second, in Kant's space there are lines, and more generally there is Euclidean geometry. And we need all of that, because in our models, numbers are space-time theology, and they are points on an infinite line, and it's a fundamental object that we don't derive from anything else. So we need space as an infinite given quantity, and we need in this space to have infinite lines as fundamental objects. Third, I want to talk about a trick to think of numbers in space. And I recently read Relativity's Special and General Theory by Albert Einstein. And Einstein uses this trick all the way up to the end, where it becomes a bit too simple for a theory. But other than that, all the way up to the end, to define space, Einstein says there's a body of reference, and then you have a rod, which is a solid like this. It is longitudinal, and you use it as a unit to measure space into one direction. And so to measure the distance between two objects or two events, you just join the same unit into the same direction, and you count how many of them you can use between the two objects. And this number is the coordinate. So that's how Einstein associates space with numbers. And I think it's a key thing, because even if we write joining extensions as sort of this line that is just into one direction, right? So there's no, and even in theory, when you think of it, in a certain sense, there is no area, there is no volume. But I think concretely, what we should think of when we join two extensions like this is actually a volume, an object with a volume that you just join with others. And when we think of space, we think of an infinite given quantity, and what this infinite given quantity gives us is these volumes of space that we just look into one direction. The Einstein trick is that when we talk about length, we talk about a one-dimensional extension, but in another sense, we also talk about a three-dimensional volume that measures that extension. And this gives us the opportunity to think of space much more concretely and much more conveniently. So when we join two extensions, we seem to join two one-dimensional extensions, but we also join two volumes that measures those extensions. The infinite given quantity allows you to extract one-dimensional extensions, but it also allows you to think of it as three-dimensional volume measuring those extensions. So when we think of an infinite line, we also think of an infinite volume measuring that line. The Einstein trick is important because it makes joining two one-dimensional extensions much more concrete. Also, when we have statements such as time flows into space, it's much easier to think of time flowing into a three-dimensional volume than into a one-dimensional extension. In the addition of the real numbers, numbers have an extension that captures a portion of space that we just described. They also have a sign. If the sign is plus, it makes the space cumulative. If the sign is minus, it makes the space subtractive. If the sign is plus minus, it means that the number is zero, so it can be interpreted just as a boundary. We call the new dimension brought by the science theology. It makes the space theological. We'll see how to add these theological spaces. We'll also provide a set theoretic description to make crystal clear what we're doing. The first case is when you add two numbers x and y that have the same signs. If x in green is positive and y in green is positive, then x plus y is positive and you just join their extensions. Same, if x in red is negative and y in red is negative, then x plus y is negative and you just join their extensions. If x in blue is a boundary 0, if y is any extension with any sign, the result of x plus y is just y. Same if x is any extension and if y in blue is a boundary 0, then x plus y is just x. The case 1 that we just covered is what happens when you add numbers that have the same signs, where the notion of same is a bit loose, which means that plus is not the same as minus, but plus is the same as plus minus, and minus is the same as plus minus. In other words, 0 have the same sign as the positives, 0 has the same signs as the negatives, but the negatives and the positives have different signs. The relation is not transitive. In each case, we join the extensions. So the addition in those cases is just joining these extension e plus e prime, e plus e prime. The direction theta 1 is just the horizontal direction. It is the same for all real numbers, so you don't have to worry about it. The sign of the sum x plus y is always a sign of x, except when x is the boundary 0. If x is 0, then the sign of the sum x plus y is the sign of y. So we have two cases. Either the sign of x, sigma, is not 0. In that case, the sign of the sum is the sign of x, sigma. Or if x is actually 0, and so its sign is actually the sign 0, then the sign of the sum is the sign of the other number, sigma prime here. The other case is when x and y have different signs, which mean one is positive, the other one is negative. Without losing any generality, let's take x as the positive one and y as the negative one. There are three cases depending on the extension of x and the extension of y. The extension of x can be greater, smaller, or equal to the extension of y. If the extension of x is greater, x plus y has an extension that used to go from y to x. It has also the sign of x. If the extension of x is smaller, x plus y has the extension that used to go from x to y. X plus y has the sign of y. If the extensions of x and y are the same, x plus y is the boundary 0, so the number 0 with the sign plus minus. Depending on the comparison of the extensions of x and y, we have three different results, and they correspond to three cases in the set theoretic description. The three new cases are cases where the signs of x and y are strictly different. In the three cases, we just subtract the extension of x and y. The comparison of the extensions, choose which extension is subtracted to the other one. The greater is subtracted by the smaller one. And here it doesn't matter because they are the same. And the sign is always the sign of the greater. Sign of x prime. And if the two extensions are the same, the sign is just a sign of 0 plus minus. As you can see, the formal description is quite complex, but in terms of space, if x and y are of the same sign, summing them means joining the extension and preserving the sign. If x and y are of different signs, summing them means taking the extension that is complementary from one to the other and keeping the sign of the larger extension. Again, we take the extension that is complementary to go from one to the other and taking the sign of the larger extension. In the language of theology, plus is good, minus is evil. Plus minus is a boundary between good and evil. When you add good with good, it makes a greater good. When you add evil and evil, it makes a greater evil. When you add a boundary, it doesn't change if it's good or evil. If you add good and evil, they fight, and the result is of the kind that prevailed because they have the larger base. So if good is larger than evil, then the result is a smaller good. You remove some of the good, but you remain good. If certain good is added to a greater evil, the result is actually evil. If a good is added to the same evil, you get the boundary between good and evil. Theology is a language that we use across our model of the real numbers. We use it because usual notions of theology map themselves nicely into the numbers. In the context of addition, the positives are mapped to good, the negative to evil. It makes the space cumulative or subtractive. The analogy is that good and evil fight. They can cancel each other. They can prevail. In the context of addition, the positives and the negatives are fully symmetric, which is not the case of good and evil in general. In our full model of the real numbers, the positives and the negatives are no longer symmetric, but the addition shows a symmetric aspect of good and evil, which is that they can fight, they can cancel each other, they can prevail. We have everything to think about addition. In our model of the real numbers, each number is a point on the line. Each point has an extension. It is the same here and here, for example. If the point is on the right, it is positive. If it is on the left, it is negative. If it is in the middle, it is a number 0 with a sign plus minus. We know how to add such theological space. If they have the same sign, we just join their extensions. If they have different signs and one is greater than the other, we just take the complementary extension, so the subtraction of one by the other. If the extensions are equal and the sign opposite, then you get the boundary 0. We also know how to think precisely about these additions using the set theoretic description. Real numbers are defined axiomatically as a complete ordered field. Axioms are sentences like these that together form a logical seed that completely define the real numbers. Some of the axioms are only related to addition. These are the axioms that we can go through at this point. I want to present these 5 axioms that are only related to the addition. These axioms here describe the real numbers as an additive group. The first axiom says that there exists a number 0, such that for every number, x plus 0 equal 0 plus x equal x. In other words, there exists a neutral element for the addition. In our model, the equivalent axiom is that there exists an extension 0, such that for all extension, this extension plus 0 equals 0 plus this extension, it equals this extension. In other words, there exists a neutral additive element in the extensions. The other condition is that 0 is the only number with a sign plus minus. This axiom says that for all pairs of real numbers x and y, x plus y is also a real number. This axiom here is usually not considered as an axiom, but as you can see, the addition that we use is based on other elements applied on the extension or the signs. We need to make sure that when you add 2 real numbers, we indeed get an object that is also a real number. First of all, we need to clarify what we mean when we say that an extension E prime is greater than another extension E. we mean that there exists an extension E double prime such that E plus E double prime equal E prime. We call E double prime E prime minus E. This definition just clarifies what we do when we do that. Here, E prime is greater than E. E prime minus E is this extension here. Once we have that, the equivalent axiom is that for any pair of extension E and E prime, E plus E prime is an extension, which means that you can join extensions, which means that when you join extensions, you get another extension. For any pair of extension E, E prime, there exists a unique E prime prime, such that E plus E prime prime equal E prime, or E prime plus E prime prime equal E, which means that for any two extensions, there always exists another extension that can be added to the smaller one to get the greater one. You always have the complementary extension that allows you to compare them and also to get the subtraction from one by the other. Okay. Finally, if E plus E prime equals 0, then you have E equals 0 and E prime equals 0. This means that 0 is the smallest extension possible. These three axioms allow you to always compare the extension E and E prime. It also always defines E minus E prime. This axiom here states the existence of the opposite. For any real number x, there exists a number x prime such that x plus x prime equal x prime plus x equals 0, the additive neutral element. The equivalent axiom in our model is this axiom here, which says that only 0 is restricted with a sign plus minus. 0 has a sign plus minus, and any extension E has both the positive number with this extension and the negative number with this extension. The 2 points are opposite because when you add them, you get the number 0, which is the additive neutral element. These axioms here are the commutativity axiom and the associativity axiom. It asserts that for any triplets x, y, z of real numbers, x plus y equal y plus x plus y plus z equal x plus y plus z. The equivalent axioms in our model are the same axioms rewritten for the extensions, i.e. for any triplet of extensions E1, E2, E3, E1 plus E2 equal E2 plus E1, E1 plus E2 plus E3 equal E1 plus E2 plus E3. In other words, the addition of extension commutes and is associative. These conditions describe directly what happens when the numbers are of the same sign. Indeed, commutativity of extensions means if the two numbers are of the same sign, for example, positive, then this extension plus this extension equals this extension plus this extension. We have just changed the order of where we put the first extension. Similarly, associativity says that when you join three extensions, it doesn't matter if you join the first extension and the second extension and then you join that to the third extension, or if you join the first extension to the second extension joined to the third extension. In practice, if you have an extension and you divide it in any number of subdivisions, associativity allows you to just join extension in the order that you want, and with the commutativity, you're even free to shift how the subdivisions appear in the final extension. The equivalent axiom of our model describes directly only the case where x, y, and z are the same sign, but you can prove that these axioms are sufficient. Commutativity and associativity is also valid in the general case where x, y, and z may have different signs. If you think of extensions with the Einstein trick, which means that you think of it as a length that is measured by a 3D volume, such as a marker, commutativity says that this length here is the same as this one. Associativity asserts that this extension here is the same as this extension here. The internal property asserts that when you have two extensions, when you join them, you get an extension, which is just a basic assumption of how you build extensions. Not only that, to have an internal addition, you need that for any two extensions, there exists a unique complementary extension filling exactly the gap between the two. Also, 0 has to be the smallest extension possible. Only the extension 0 can join itself into the extension 0. Regarding the neutral element and the existence of the opposite, you could be tempted to use Poincaré interpretation of space. The 0 would be a reference perception, and then x would be a movement, and x prime here would be the opposite movement, bringing back to the original perception. It is tempting because when you add the opposite, you could interpret it as going from there to there, and going back from there to there. The movement interpretation is tempting and somewhat valid, but it is actually a dead end. You have to remember that space is an infinite given quantity. There is no movement, there is no time of movement. The way we cancel numbers with each other is by having a cumulative and a subtractive dimension within a single time t equal 1. The opposites are just the numbers with the same exact extension, but different signs. The 0 is not the initial perception of Poincaré or the body of reference of Einstein. The 0 has a neutral extension and a specific sign, plus minus, that we can interpret as a boundary between good and evil, where good is associated with the cumulative aspect of space and evil with the subtractive aspect of space. In this video, you have seen many aspects of space in theology. The main one being that there is a cumulative aspect of space, a subtractive aspect of space. We interpret the cumulative as good, the negative as evil. They can fight, they can cancel each other, they can prevail. These new dimensions are key to conceive an infinite given quantity whose parts on the line can cancel themselves. Feel free to check more videos on the channel to understand the full model of real numbers as space-time and theology that allows you to think of the line of the real numbers as a complete ordered field.